Okay, so again, we have one more rational function. I'm going to start by factoring. So the top does factor is the difference of two squares, x plus 2, x minus 2. Your denominator will factor to be x plus 2, x plus 1. Okay, now again, here's one where you have to be a little bit careful. We clearly have a common factor here, x plus 2. We don't want to cancel. If we cancel, we're going to mess up our denominator. Okay, this is factored form. Nothing has happened to the function except I rewrote it. Once I start canceling, then you're changing the function. Okay, and I don't want to change it. All right, so my first question again is domain. Any number that makes the denominator 0 has to get thrown out. So clearly x can't be negative 2 or negative 1. Okay, so then the immediate follow-up to this is there a vertical asymptote or a hole at each of these places? We know there's no point there because those are not in the domain. Okay, but what is happening there? And for rational functions, any number at which there is no graph because it's not in the domain, there has to be a vertical asymptote or hole. Okay, now to figure out this one, that's when we use our reduced function. So it's a different name because when you cancel, when you reduce, you're changing the function just a little bit. So I'm going to call it y tilde. So the x plus 2 is canceling, I'm left with x minus 2x plus 1. So I'm going to use this to plug in. So if I look at y tilde at negative 2, right, you get negative 2 minus 2 over negative 2 plus 1. So that's negative 4 over negative 1 or 4. Okay, nothing undefined. Again, we know it's not in the domain. We know it makes the original function have a denominator 0. But in the reduced function, if we plug in negative 2, we get 4. So again, in our original, that will be a hole. Okay. Similar over here, we take y tilde of negative 1. Okay, so again, we plug in negative 1. We get negative 1 minus 2 over negative 1 plus 1, which is negative 3 over 0, right? That's undefined. It's still undefined. Okay, so that means there will be a vertical asymptote there. Okay, so the two places that are not in the domain, one turned out to be the hole, the other one is a vertical asymptote. All right, we check for horizontal asymptotes or oblique asymptotes. So remember, you're looking at the leading coefficients. So since the degrees are tied here, we take the ratio of leading coefficients, which is 1 over 1. So we have a horizontal asymptote at y equal to 1. Now we're just looking to get a couple points. So does it cross the horizontal asymptote? So we solve, again, does the function x squared minus 4 over x squared plus 3x plus 2, does it ever equal your asymptote here, y equal to 1? Okay, so with clear fractions, so we'll bring this up to the other side. So we have x squared minus 4 equals x squared plus 3x plus 2. Subtract out the x squareds. We could subtract 2, divide by 3. We get x equal to negative 2, which we'd be tempted to say, okay, it does cross. But remember, this is not in the domain. So the answer here is that the graph does not cross the horizontal asymptote of y equal to 3. Y equal to 1. Okay. So there's no point at which we should cross it. And then E is our intercepts. X-intercepts, remember we have to solve. We set our function. X squared minus 4 over x squared plus 3x plus 2 equal to 0. Okay. Remember, you could multiply both sides by the denominator, it'll just be 0 on the right still. Or in a fraction, you know, the numerator has to be 0 for the whole thing to be 0. So again, it will look like plus or minus 2. Can't be negative 2. Negative 2 is not in the domain. So x equal to 2 is our only solution here. So 2 comma 0 is the only x-intercept. Y-intercept, remember, you're just plugging in 0. So y of 0 is negative 4 over 2 or negative 2. So the point 0, negative 2. And now we'll just graph. So again, the first thing we have a vertical asymptote back here at -1. We also have a hole, remember, at -2, 4. So our graph doesn't pass through this point, but it just jumps over it. Okay. We have a horizontal asymptote at 1. Remember, horizontal or oblique, in this case it's horizontal, means we begin our graph here, end it there. Okay, we also found in part D, remember that we never cross this. Okay. And then we have a couple of intercepts. So we have the point 2, 0. We also have the y-intercept at 0, -2. Okay, not a lot to go on, but again, the hole, right, is not a point, but we jump over it. So again, we have to start here, hit this point, so apparently we're going to have to go up. We can't go down because we can't cross the horizontal asymptote. We found out in part D that our graph does not cross the asymptote. So we'll just start here, jump over the hole, and go up. And then similarly down here, right, we have points down here. We have this point and this point. So we clearly can't be up here. We hit those points. Remember, never cross the vertical asymptote. And in our case, for this problem, we decided in part D that we can't cross the horizontal. So we get a graph that looks like this.